Hi guys, welcome to our next video. Today we'll be talking about compass and true bearings. Now, bearings is basically just a way of us finding a direction from one point to another. And how we do that is we are talking about the direction using north and south as a reference point. So compass bearings is really talking about when you're given north or south and then the degrees at the end and east and west. Basically, if we start off and describe this point south 60 degrees east, what we'll do is we'll find out where south is, and then we know that east is in this direction. So we move 60 degrees into that direction. Now, the problem with compass bearings is that it's not consistent with other bearings, because sometimes we use north, sometimes we use south, and so another way of finding bearings is called our true bearing. This is when we always use north as a reference point, and then we work out where everything is around that. So there's two instructions to find a true bearing of something. We start at north, and then what we'll do is go clockwise until we get to our bearing. So that's this example shown there. Now what we're going to do is practice these bearings and find both the compass bearing and the true bearing at these two different points. And there's actually shortcut methods to find all these points. So for our compass bearing, what we first of all need to find out is this angle here. Now to find that angle, what we need to know that it's 90 minus 30 degrees. Okay, that's not meant to be a 300. And what we know is that 90 minus 33 is 57 degrees. So this here is 57. So our compass bearings would be written as south and then 57 degrees west, because we're going 57 degrees to the west. Now, with our true bearing, there's two different ways of solving this. One is knowing that south is actually just 180 degrees. So what we can do is if we do 180 plus 57, that gives us 237 degrees, and that is our true bearing there. Now, if we didn't know the 57, what we could also do is if 90 degrees is east, 180 degrees is south, 270 degrees is west, we could also do 270 minus 33 and actually get our same answer there. Alright, so our compass bearings for the next point, we know that this is a complementary angle, so this has to add up to 70 degrees, and so we'll be going north 70 degrees east, and then for our true bearing, that would just be the same as 70 degrees true. Alright? And our last compass bearing is this side here is 90 minus 35, which should be 55. And so we are going north 55 degrees west. Okay? And our trick before, we were like, hang on, 270 plus 35 must equal 305 degrees. And so our bearings are listed all below here. Okay, on to the next page. What we're looking at next is finding the compass bearings to and from different points. So we start facing north, we go 30 degrees to the east, and that is our compass bearing. On the flip side, from O to B, we'll notice that's below our halfway line, so that means we're starting from the south. This line here says it's 120, therefore the remaining angle must be 60, so this compass bearing is south 60 degrees east. These examples here, when we try and find the true bearing of C from O, that means we're starting from O, we're going to C, that is just going to be quite easily 210 degrees true, as listed there. And on the flip side, what we said before is 270 plus our 60 means that this bearing from O to D is 330 degrees true. as well, because that's 270 plus 60. Now, we're going to go straight to this example here. Find the true bearing of y from z. So we start at z, we look north, and we see how far we need to rotate till we get to y, and that's just 62 degrees. Okay, so that's the answer to question A there. On the flip side, the answer to question B is from x, what do we need to go to y? Now, girls, if you notice that this is a straight line here, that means 180 minus 41 gives us 139 degrees, and that is our true bearing from x to y. The last thing we need to find is our bearing from y to x. Now, girls, if there isn't a line facing north, I would suggest you draw one in. We then also need to roll around clockwise. And the thing about this is we know that this angle here is 41 degrees. Okay? If that's 41 degrees because these angles are alternate, then that means we can just do 360 minus 41, and that will give our true bearing, which is 319 degrees. So, in our next example, a triathlete runs 10 kilometers on a bearing of 200 degrees from the end of a cycling leg to another. What we need to do is find out how far south does the triathlete run. Now, we're going to draw a diagram in there first. So basically, because we know that the bearing is 200 degrees, what I'm going to do is I'm going to draw north here, and I'm going to draw a line like that, which is 10 kilometers. And we know that whole thing is 200, but this little angle in here will just be 20, because we know 180 degrees cuts like that. And so I'm going to draw my triangle like so. We also want to just find out how far south the athlete runs. And so what we've basically got is a SOHCAHTOA question again. This side's the opposite, this side's the adjacent, this side's the hypotenuse. So what we can do is use the cosine rule. So SOHCAHTOA means cos theta equals A over H. Then we can write cos 20 equals A over 10, and then solve this problem like so. Alright, so what I'm going to just do is type that in my calculator quickly. 10 cos 20 gives us 9.397. To the nearest kilometer, that's just 9 k's. Now, with our other question, for question B, it's asking us what is the bearing of the end of the cycling leg from the finish line. So this is the cycling leg over here, this is our finish line, alright? And so we need to work out this angle from this point to that point. Now what we already know is that that's 20 degrees, therefore this must be 20 degrees, so our question is just 20 degrees true, or north 20 degrees east. This is the true bearing, this is the compass bearing, it doesn't really matter which answer you give us. Our next example is talking about Jonas riding his kayak from one buoy on a bearing of 135 for 4.2 kilometers, and then at a second buoy he turns and then is at a bearing of 0.45 degrees and continues for 2.8 kilometers. What is his true bearing from the finish line to the start buoy? So for this question, what I would do is I would start to label what I know. So what we do know is that the bearing is 135 degrees over here. That means that's 45 degrees down there and 45 degrees here because these angles are alternate angles. What we also know is buoy 2 to buoy 3 is also at 45 degrees. And when we add that up, we realize that that's actually a nice right angle triangle that we've made with these 3 points. What we also know is the distance between this point is 4.2 and the distance between these points is 2.8. And what we could use is Pythagoras to work this last line, but we only really care about the true bearing from those boys to the other boy. Now, if we look at the total bearing here, we know that that's going to equal to 135. But what we also want to do is minus this angle of the triangle so we can actually work out the bearing that's left over here. Okay, this might be a little bit confusing for now, but just bear with me as I go through this question. So here we know the angle is 2.8 and 4.2. What we're going to use is SOHCAHTOA equals 4.2 over 2.8. And then when we push shift tan equals 4.2 over 2.8, we end up with an angle of 56 degrees and 19 minutes. So this angle in here is 56 degrees and 19 minutes. Now, what we know about this point here is 1 full revolution is 360. What we also know about this point down here is that it's 45. And what we do also know about this angle here, we found is 56 degrees and 19 minutes. So what I'm going to do is I'm going to add 56 and 19 minutes with 45. And what that gives me is 101 degrees and 19 minutes. Now, if the bearings from north to south is 180, and we're also adding this 101.19 minutes, therefore the true bearing from the finish line all the way back to boy 1 is 281 degrees and 19 minutes. Now, that was a very complicated way of solving this, and I'm sure you probably should be able to solve it a little bit easier, but that's just my method of solving this question so far. Hopefully the next few will be a bit easier. If we're going north and 10 degrees east, then this will be our sketch like so. If we're going south and 25 degrees west, that will be our angle like so. If we're going north and then 60 degrees west, that will be our angle like so. And if we're going south and 42 degrees east, that would be like this angle. Okay, so that's how we can sketch some of our compass bearings. With our parallel line properties, these are some things you just need to remember. And just a reminder, whenever you have any sort of bearing questions, please think about extending all the lines just so you can map out every single angle. So we're going to just finish off with these questions. Mia cycled 15 kilometers west and then 24 kilometers south. The angle of theta to the nearest degree. So again, the diagram is drawn here for us, but in case you didn't understand, 15 west is this direction, 24 south is that direction. We basically have a right angled triangle. So what we can work on is using tan theta. This is the opposite, this is the adjacent, and then solving for this. So inverse tan of 24 over 15 equals 58 degrees. Now, if this point is 58 degrees, and we also know that this angle straight west is 270, to find our true bearing from our starting point, what we can do is just 270 minus our answer. And what that gives us is 212 degrees. if we are working out Mia's compass bearing from her starting point, all right, so instead of 212 degrees, we need to think about how much we need to add from 180 to get 212. And how we can do that is just have our answer minus 180. So we end up with south and then 32 degrees west. All right. The last example we're going to do together is this one here. Calculate the distance between A and B. Okay, the last example we're going to do together is like this. Amelia walked from point A for 1 hour in the direction of 51 degrees east to reach the point B, and then 2 hours heading south until she reached the point D. So if she's walking at 5 kilometers per hour in her journey, that means she's walked 5 kilometers here and then 10 kilometers there, just to make up our distances. So we've got the numbers 5 and 10 like so. So the distance walked from A to B is 5 kilometers. So the distance she walked to A to B is 5 kilometers. The distance she walked to B to C. Now what we need to know is that we've got another triangle like so. We don't know that distance from B to C, but what we do know is that this is 5 kilometers, but more importantly, these are complementary angles again. So what we're going to do is 90 minus 51 gives us 39 degrees. We're going to label our opposite, label our hypotenuse. Notice that O and H is the sine SO. So sine 39 equals opposite over hypotenuse. 5 times sine 39 equals to our unknown, which totally equals 3.15 kilometers. Now, what we also worked out from this point here from B to D is if she walked for 2 hours, that means she traveled a total of 10 kilometers. So, if we do 10 minus 3.15, we end up with our answer, which is 6.85 kilometers traveled from C to D. As we can see from our diagram, this looks quite even, but in reality, 3.15 is quite different to 6.85. Alright, so now we want to calculate the distance from A to C. What we can do is just some old Pythagoras. So we've got our right angle triangle here. We don't know that distance. We do know that this distance is 3.15, and we do know that this distance is 5. So what we can do is 5 squared minus 3.15 squared all under square root is our distance. Okay, and so when we just type that in our calculators, we should get 5 squared minus 3.15 squared. We end up with 3.88 kilometers. Okay, and then to work out question E, we can use Pythagoras again. Okay, so this time we've got the triangle like so. We are trying to work out our hypotenuse. We have just worked out that this distance is 3.88. From part C, we also know that this distance is 6.85, and so A squared plus B squared equals C squared, but that also means that C equals square root of A plus squared plus B squared, and when we put these numbers into our calculators, we end up with 7.87. So that's the distance between A and D. Okay? The last thing we need to work out is the compass bearing needed for Amelia to return to her starting point. Now, this is a lot easier than we think because our compass bearing is really just about starting from north, finding how many degrees we go west until we get that answer. Now, what we know already is that this angle here is 51 degrees, all right? But what we also know that is, what we also know is that we've got a right angled triangle like so with our numbers we have just found together then, 6.85 and 3.88. And we want to find this angle here. So the easiest way to do that is to label our sides opposite and adjacent. Tan theta equals 3.88 over 6.85. That means our theta is inverse tan of 3.88 over 6.85. And when we type that in our calculator, we end up with our degree of 30. So the compass bearing from D to A is north 30 degrees west. Okay, so sorry that was quite messy, but hopefully that makes sense.